All right, so we're gonna take a look at our last little lesson in this unit section that we are working on here. So we're gonna talk about more pairs of angles, angle pairs. So our first angle pair is what we call vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays, or two angles with a common vertex but no common sides. So for example, okay, so here we have a little diagram here. So a pair of vertical angles is angle 1 and angle 3. Because they're across from each other, they're formed by opposite rays and they share a vertex point. Okay? And the other pair of vertical angles is angle 2 and angle 4. Okay. Now, from our last lesson, we learned about something called linear pairs. Now, in this diagram, there are 4 sets of linear pairs. Okay, so let's kind of talk about them. So remember, linear pairs are adjacent supplementary angles. Okay, so an example of a pair of linear pairs is angle 2 and angle 3. Another pair is angle 3 and angle 4. Another pair would be angle 1 and angle 4. And another pair would be angle 1 and angle 2. Okay. So these are linear pairs. Now, important fact to remember, so pairs of vertical angles are always congruent. So they have the same measure. Okay. All right, so let's take a look at this diagram. So in this diagram, we want to name all pairs of vertical angles and linear pairs of angles in the diagram below. So let's start with linear pairs. So again, linear pairs are adjacent supplementary angles. Okay. So a pair of linear pairs that I'm looking at is angle 5 and angle 1. Angle 4 and angle 5. Now we have to be careful. So even 2, 3, and 4, technically they form a line. We got to think about what the word pair means. Pair means 2. Okay. All right. So let's talk about let's think about some vertical angles. So some vertical angles would be angle 1 and angle 4. And I think that is it. Okay. There would be more if we added angles together, but again, pairs of angles means 2. All right, so let's go to the next page. So we have line AB and PQ intersect at point F. So let's draw a little picture. The measure of AFP is 7n plus 8, and the measure of BFQ is 5n plus 20. Okay, so we're going to set up and solve an equation to find the measure of each angle's form. Now, these two angles that they talked about in this question are what we call vertical angles, and vertical angles are congruent. Okay. So since they are congruent, they have the same measure. So we're going to set these two things equal to each other. So 7n plus 8 is going to be set equal to 5n plus 20. Okay. So we're going to minus 5n both sides. So 2n plus 8 minus 8 both sides. So 2n is equal to 12. So n is equal to 6. However, we want to find the actual measure. So we're going to take 6, and we're going to plug it into one of the expressions. Now, once we find one angle, we can find the other. All right? So if we, I don't know, we can use 5, this one. Okay, so the measures of the angles are 50 degrees. Now, here's the thing. In geometry, we're going to be given a lot of diagrams, and we're going to be asked to conclude some things from the diagram or from what they tell you in the question. Now, we just have to be careful that to not assume things just solely based on what is given to you in the diagram. Okay? You kind of have to think about it. It may seem like you can know something, but maybe not. Okay? So let's take a look at what I mean. So here we have a diagram. Okay? And now, just solely based on this diagram, these are some things we can conclude. So let's take a look at them. Things that we can just automatically assume. All right? So we can assume that all points shown are coplanar. Points A, B, and C are collinear, and B is between A and C. Line AC line AC, ray BD, and ray BE intersect at B, point B. DBE and EBC are adjacent angles. ABC is a straight angle, and point E lies on the interior of angle DBC. So, okay, so some obvious stuff, right? Now, here's the thing. We are going to want to say a bunch of other things, like, for example, that this is a right angle, okay? Now, because that there's nothing telling us that that's a right angle, we can't just automatically assume that, right? Now, another thing you guys are going to want to say maybe is that AB, so say if this was a segment, AB is congruent to AC. There's not necessarily anything telling us that that is the case. Okay? I mean, it looks it, but we don't know that, right? We could also say that something that we may not be able to conclude is that ray BE bisects angle DBC. Okay, so that's, I mean, it looks it, but we weren't told that, so we can't just assume that. All right. Now, what if the diagram changes? What if we were told that what we thought or what we should think is true is actually true? So this is how you guys would see this. So say if ABD is a right angle, then you would either be told that this is a right angle, you would be told that BD is perpendicular to AC, or you would be given a little box, right? A little square in the corner of the angle. Okay. Now, if you were told that AB is congruent to BC, then you would have little tick marks, okay? I mean, A and C would also be points. Now, if this was true, you guys would either be told that BE is the angle bisector of DBC, or you would be given a little angle mark saying that those two angles are equal. Okay? So you guys are going to hear me say never assume or don't make stuff up. Keep that in mind, right? So only go off of the diagram and kind of what they tell you in the question. Don't automatically assume that you know, this is a right angle or this is an angle bisector, because it is kind of confusing sometimes. Okay.